Have you ever felt like the world is too perfect, like everything is following a script? This feeling, while unsettling, is at the heart of a fascinating question. Are we living in a simulation? It might sound like science fiction, but some philosophers and scientists believe it's a real possibility. What if our reality, with its intricate laws and vast universe, is just a sophisticated computer program? This isn't just a thought experiment. There are compelling reasons to take this idea seriously. Let's explore the simulation hypothesis and delve into the evidence that suggests our universe might be a carefully crafted illusion. The simulation hypothesis proposed by philosopher Bostrom suggests that we might be living in a computer simulation created by a highly advanced civilization. Imagine a civilization with computing power beyond our wildest dreams, capable of creating universes as easily as we play video games. Bostrom argues that if such civilizations exist, they likely run ancestor simulations, detailed recreations of their evolutionary history. If they run enough of these simulations, it becomes statistically more likely that we are living in one, rather than being the original civilization. Think about it. The sheer number of simulated universes compared to the one real universe makes it statistically improbable that we are in the original. It's like flipping a coin a million times. The odds of getting heads every single time are astronomically low.
The idea of questioning reality isn't new. For thousands of years, humans have grappled with the nature of existence and the reliability of our perceptions. Ancient philosophers, from Plato to Aristotle, debated the essence of reality and whether our senses could be trusted to convey the truth. They wrote extensively on these topics, leaving behind manuscripts that continue to intrigue and challenge modern thinkers. Centuries ago, philosopher René Descartes famously pondered, "How do I know I'm not just a brain in a vat being fed sensory information?" This radical idea wasn't just a whimsical thought, it was a serious philosophical inquiry into the nature of knowledge and existence. Descartes' skepticism led him to the famous conclusion, "I think, therefore I am," suggesting that the act of thinking is the only undeniable proof of one's existence. This thought experiment, while extreme, highlights the fundamental problem of perception. How can we be sure that what we perceive as reality is actually real? In today's world, with the advent of virtual reality and advanced simulations, these questions are more relevant than ever. The lines between the virtual and the real are increasingly blurred, making us question the very fabric of our perceived reality.
Fast forward to the 20th century and quantum physics throws another wrench into our understanding of reality. The discoveries made in this field have fundamentally altered our perception of the universe. Scientists like Niels Bohr and Albert Einstein debated the implications of quantum mechanics, which seem to defy the classical laws of physics. The double-slit experiment, for example, shows that light can behave as both a wave and a particle, depending on whether it's being observed. This experiment is one of the most famous in quantum mechanics and has profound implications for our understanding of reality. It suggests that the act of observation can alter the behavior of particles, challenging the notion of an objective, observer-independent reality. This bizarre behavior suggests that observation itself might influence reality, blurring the lines between observer and observed. It raises questions about the role of consciousness in shaping the physical world. Are we passive observers of a pre-existing reality, or do we play an active role in its creation? These philosophical and scientific inquiries challenge our assumptions about the nature of reality. They force us to reconsider what we know and how we know it. The debates among scientists and philosophers continue to this day, as we strive to understand the true nature of the universe and our place within it. They suggest that what we perceive as solid and objective might be far more malleable and subjective than we realize. As technology advances, we may find that our understanding of reality is just the tip of the iceberg, with deeper, more complex layers waiting to be uncovered. The journey to understand reality is ongoing, and each discovery brings us closer to unraveling the mysteries of existence.
Quantum mechanics, the study of the universe at its smallest scales, reveals a reality that is stranger than fiction. It delves into the behavior of particles so minuscule that they defy the conventional laws of physics. These particles, which form the very foundation of everything around us, exhibit behaviors that are not just unusual but downright baffling. Subatomic particles, the building blocks of our world, don't behave like the solid objects we're used to. Instead of following predictable paths, they move in ways that seem almost magical. They can be here one moment and there the next, without any clear transition. This unpredictability is a hallmark of the quantum realm. They exist in a state of superposition, meaning they can be in multiple states at once until they are observed. Imagine a world where a single particle can be in two places simultaneously, or spin in two directions at the same time. This superposition is only resolved when we observe the particle, forcing it to choose a single state.
This concept, known as wave-particle duality, challenges our everyday understanding of reality. Light, for instance, can behave both as a wave and as a particle depending on how we observe it. This duality is not just a quirk of light but a fundamental aspect of all quantum particles. How can something be in two places at once? This question strikes at the heart of quantum mechanics. It defies our classical intuition and forces us to rethink the very nature of existence. The idea that particles can exist in multiple states simultaneously is not just theoretical, it has been demonstrated in countless experiments. How does observation collapse the wave function and force the particle to choose a single state? This phenomenon, known as wave function collapse, is one of the most mysterious aspects of quantum mechanics. It suggests that the act of measurement itself plays a crucial role in determining the state of a particle. These questions have puzzled physicists for decades, and while there are various interpretations of quantum mechanics, none of them fully explain the strangeness of the quantum world. From the Copenhagen interpretation to the many worlds theory, each offers a different perspective but leaves us with more questions than answers. Some physicists even suggest that these bizarre behaviors could be evidence of a simulated reality, where the rules of physics are not as fixed as we think. In this view, our universe might be akin to a complex computer simulation, with quantum anomalies hinting at the underlying code. This idea, while speculative, opens up fascinating possibilities about the nature of our existence. Section 5. Limits of reality. Our universe, for all its vastness and complexity, operates within certain limits. One of the most fundamental is the speed of light, the cosmic speed limit that nothing can exceed. This limit, while crucial for the functioning of our universe, could be seen as a constraint imposed by the simulation itself. Imagine a vast, simulated universe running on a complex computer program. To prevent inconsistencies and paradoxes, the program might impose a speed limit on information transfer, ensuring that cause and effect remain consistent throughout the simulation. This is just one example of how the limitations of our universe could be interpreted as evidence of a simulated reality. The finite resolution of spacetime, the quantization of energy, and the existence of fundamental constants could all be seen as parameters set by the programmers of our simulated world.
Section 6. Glitches in the code. If we are living in a simulation, it's not unreasonable to think there might be occasional glitches in the code.
These glitches could manifest as strange phenomena that defy our understanding of the laws of physics and logic. Some people believe that experiences like déjà vu and the Mandela Effect could be examples of such glitches.
Déjà vu, the eerie feeling that you've experienced something before, could be a result of a brief lag or error in the simulation's rendering of your consciousness.
The Mandela Effect, where large groups of people have shared false memories, could be a sign of a larger-scale error or alteration in the simulation's code.
While these phenomena have been explained by psychologists as memory errors or social contagion, the possibility that they are glitches in a simulated reality remains an intriguing, albeit unprovable, hypothesis.
Section 7. Simulated reality. The rapid advancement of technology, particularly in the fields of artificial intelligence, virtual reality, and brain-computer interfaces, further blurs the lines between reality and simulation. These technologies are evolving at an unprecedented pace, making it possible to create experiences that are increasingly immersive and lifelike. From sophisticated AI that can mimic human behavior to VR environments that transport us to entirely new worlds, the boundaries of what is real and what is simulated are becoming ever more fluid.
We are creating increasingly realistic virtual worlds, and technologies like Neuralink promise to seamlessly merge our minds with machines. Imagine a future where our thoughts can directly interact with digital environments, allowing us to experience and manipulate virtual worlds as naturally as we do the physical one. This integration could revolutionize not just entertainment but also education, healthcare, and even our social interactions.
If we continue on this trajectory, it's not far-fetched to imagine a future where we can create simulations that are indistinguishable from reality. These hyper-realistic simulations could offer experiences that are richer and more varied than anything we can currently imagine. They could allow us to explore fantastical worlds, relive historical events, or even create entirely new realities tailored to our desires. And if we can create such simulations, who's to say that we aren't already living in one created by a more advanced civilization? This idea, often referred to as the simulation hypothesis, suggests that our perceived reality might be an elaborate digital construct. It challenges our understanding of existence and raises profound questions about the nature of consciousness and the universe itself.
The convergence of these technologies forces us to confront the possibility that our reality is not as objective and independent as we once believed. As we delve deeper into the realms of AI, VR, and brain-computer interfaces, we must grapple with the philosophical implications of a world where the line between the real and the simulated is increasingly blurred. This new paradigm could fundamentally alter our perception of reality and our place within it.
It raises the question, at what point does a simulation become indistinguishable from reality? And what does that mean for our understanding of our place in the universe? As we continue to push the boundaries of technology, we may find ourselves questioning the very fabric of our existence, pondering whether we are the creators of our own simulated realities or merely participants in a grander design.
Section 8. A universe of consciousness. One of the most profound questions raised by the simulation hypothesis is the nature of consciousness in a simulated world. If our minds are just lines of code in a computer program, does that mean our thoughts, feelings, and experiences are ultimately illusory? Or could it be that consciousness is a fundamental property of the universe, something that transcends the limitations of any simulation? Perhaps even a simulated universe can give rise to genuine consciousness, just as complex as our own. This question touches on the very essence of what it means to be human. It challenges us to consider the possibility that our subjective experiences, the very core of our being, might exist independently of the physical world, even within the confines of a simulated reality.
Section 9, real or simulated? So, are we living in a simulation?
The truth is, there's no definitive way to know for sure. The simulation hypothesis, while thought-provoking, remains just that, a hypothesis.
We lack any concrete evidence to prove or disprove it.
But even if we can't definitively answer the question, the very act of asking it forces us to confront our assumptions about the nature of reality, the limits of our perception, and the potential for consciousness to exist beyond the physical world as we know it.
What do you think? Is our world real, or are we just characters in a sophisticated cosmic video game?
Share your thoughts in the comments below. And in our next exploration, we'll delve into the mysteries of black holes, those enigmatic cosmic entities that challenge our understanding of space, time, and the very